All right, so next up for reviewing this test, we got chapter 4, the balancing equation part, right? So the first thing is, what is a reactant? Reactants show up on this left side of the equation, and so these are all reactants. And so in chemistry, we take reactants and then we turn them into products, which are on this right side. And then in between here, we have this arrow. So we take reactants and turn them into products. That's what chemistry is all about. Finally, here we have the coefficients. The coefficients are the numbers right in front of here. So there are no numbers right now. And so whenever there are no numbers, we assume that there are ones everywhere. Cool. So that should take care of how to write a chemical equation. Next up, we have how to balance a chemical equation. So we'll do it with this example. You can take a look in your notes, your lab, all kinds of stuff. So just remember some tips. The first thing is to start with things that are found in only one compound on each side. Right. Next tip is you can use fractions as coefficients as long as atom numbers stay whole. We'll see an example of that in this one. And then finally, the last tip is you can group polyatomic ions together if they don't change. So if you have like a phosphate on one side and it's a phosphate on the other, you can group it together. If you have a phosphate on one side, then it turns into a phosphite. They're different things. So at that point, you cannot group them together. So let's do an example of just one example of balancing chemical equation with this guy right here. So the first thing you're going to determine is if your equation is balanced. So you're going to, in this case, we have carbon, hydrogen, and oxygen. This is the way I do it. You don't have to do it this way. You can do it whatever way you want to do it, but I'd like to do the left side, the reactants, and then the right side, the products. So left side, reactants, right side, products. So currently we see that we have one C4 or 4 carbons, right? So 4 carbons right there. Here we have 10 hydrogens. And then we have 2 oxygens. Cool. And then we take a look at the product side. So here we have 1 carbon. We have 2 oxygens from here. And then we have a 3rd oxygen right here. So in total, we actually have 3 oxygens on the product side. And then we have 2 hydrogens from this water on the product side. So as you can see, none of these are balanced. So we want to go ahead and balance it. And remember, the only thing we can change is the coefficients, in this case, the ones. You can't change, you can't make C4 into C5 or anything like that. All you can change is these coefficients out front. So let's take a look at what we should do. So you can see that all of our stuff is unbalanced. So the next question is, where do you start? And so we're going to use one of our tips here, right? So start with the thing that is found in only one compound on each side. So in this case, the carbon, you can see it's only found here on this side, and it's only found here on this side. So we could start with carbon. Hydrogen, it's only in the C4H10 and only in the water. So you could start with hydrogen. And then oxygen, here only in the O2, but here in the carbon dioxide and the water. So you do not want to start with carbon, with oxygen. Do not start with oxygen. And then in terms of which one do you want to start with? Well, it doesn't really matter between carbon and hydrogen. So you just kind of got to pick one. So in my case, I'm just going to arbitrarily pick carbon. So we see that the products needs more, right? This is a 4, this is a 1. So our products needs more. And so we can delete out this 1 and replace it with a 4. And so now we have 4 CO2s. So now we have 4 carbons as our product side. But then you can see this 4 distributes in. So this becomes actually 8 oxygens. And then we still have 1 more oxygen over here, for a total of 9 oxygens on the product side. 9 oxygens on the product side. Cool. So next up, we got to balance the hydrogens. Here we see that we have 10 and 2. So we need more on the product side. So if I need 10, I need to switch this 1 to a 5 because 5 times 2 is equal to 10. And so then I'll have 10 hydrogens over here, and that switches out the number of oxygens I have as well. So I have 8 from the CO2, and then I have 5 from the water for a total of 13. So my carbons are looking balanced, my hydrogens are looking balanced, but my oxygens are not looking balanced. So if I come over to this side over here, what I can see is I need this to turn into a 13 oxygens. But I have O2, and in order to get to 13, that would be times 6.5. 6.5, right? 2 times 6.5 is 13. And so can I use fractions? Yes, I can. It's actually one of my tips right here. I can use fractions as coefficients as long as the atom numbers stay whole. So when I switch this out for a 6.5, I still have a whole number of oxygens. I still have 13 oxygens. So I am allowed to do that. And this will make balancing equations a lot simpler. So now I can see everything is balanced. My carbons are balanced. My hydrogens are balanced. My oxygens are balanced. So I'm looking pretty good. The main thing I have to remember, though, is I can't leave this as a 6.5. I can't have that in the final answer. So I need to make that a whole number. In order to make 6.5 a whole number, I have to multiply by 2. And so I have to do that to the whole equation. So this becomes then 2C4H10 plus 13 O2 going into 8 CO2 and 10 H2O. Now, I think I'm balanced. What should I always do? I should always double check. So on my reactant side, I have carbon, oxygen, and hydrogen, carbon, oxygen, and hydrogen. So let's see. Here I have 2 times 4, so I have 8 carbons here. Here I only have carbons on this side, so just 8 carbons right there. For oxygens, I have 2 times 10. For hydrogens, I have 2 times 10, so hydrogens, I have 20 of them. And again, 10 times 2, I have 20 hydrogens on this side as well. And then finally, for oxygens, I have 13 times 2. That's 26 oxygens on this side. I have 8 times 2. That's 16 right there. And then 10 times 1. That's 10 right there. That's 26. So my equation is indeed balanced, and I am done here. So we used all the tips except for grouping the polyatomic ions together because we didn't have any polyatomic ions here. But if you want to check out that hint, you can take a look at another exercise from either lecture or from your lab.